Welcome back to another LeetCode video. Today we're going to be solving 268 missing number. Maybe I've solved this one before, but I just learned some cool new stuff, so I just wanted to share it with you guys. So this says, given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. So we can see here 2 is missing. Here 2 is missing again. And here 8 is missing, right? So what I learned recently was a linear time sorting method, but it's only for certain conditions. That's why I picked this one, because it's a range of unique numbers, right? So it's called cyclic sort, cycle sort, something like this. And this is how it works. Because they're all unique and all the ranges are the same, we can swap every element to its own index, right? So if it's a, see here, if it's a 0, you just put it at index 0, and then whatever was at index 0, we put it to index 3. But here, since it's a 3 and we don't have spot for it, we just ignore it. But and then, for example, 1, we put it at index 1. And then the cool thing about this one is that if we ignore this 3, right, if you look at the length of this, then it's 2, and that's our output. Same thing for here, and it would be the same thing for here as well, unless if it's in the middle, like here. Let's see what's missing. Now I'll just show you guys, right? So what we do is we initialize a count, right? So we'll do I, because we're coders, and then we just loop, right? So I less than the length of nums. Current will be the index of the current right? Number. So let's say this is going to be a 3, right? So we'll ignore it. So we do if current is less than the length of nums. So 3 is not less than the length of nums, so we would ignore it. And nums at I doesn't equal nums at cur. That means that the item's not in their own index. We just do a swap, right? So there's some way to do swaps in Python, but this one is language ambiguous, so just use this one. And then we set it to a temporary variable. Now we can swap it. Goes nums at cur, and then nums at cur equal temp, and then else we just increment. So this is linear time sort, right? And then out here, now we can just check every item and its index, and if they're equal, and if we find one that's not equal, then we can just return that, right? So for I in range len nums, if nums at I doesn't equal I, we return I. Here we could have returned this I, but since we overrode it here, we just can calculate the length again. So return len nums. Go ahead and run this. Submit. And as you can see, this is not super slow. I mean, 100 milliseconds fast, but it's not that fast. So let me show you guys the fast solution, but I just like this one more because you could use the cyclic sort. I'm gonna drop a lot of videos about this tonight. So if we look at this, right, we can notice something really cool, that what would be the sum of all numbers from 0 to 3, right? Let's do it here. So we'll do 1 plus 2 plus 3. This is 6. And then now let's get the sum of this. Well, it would be like 0 plus 1, but doesn't matter. 3 plus 0 plus 1. when we minus these, we get 2. And that's our result, right? So instead of doing a linear time, this is it's gonna be constant because of this proof I'm gonna show you. Let's do it here again. 1 plus 2 is 3. 0 plus 1 is 1. The difference is 2. And trust me, it works for this one too. So this is how it's gonna work. So we can do one line, but actually no, this won't be. Yeah, this will still be O of n, but this will be one pass, and that's just to get the sum. Okay, so let me show you guys. So we just do return len nums times len nums over, oh no, it's plus 1 over 2 minus sum nums. So this proof is really cool. It's basically like this, like n times n plus 1 over 2. And I've probably showed this a couple times, but this basically just gets the sum of all numbers between 0 to n. And another cool thing is that it was made by this guy named Gauss or Gauss, famous mathematician. So let's go ahead and run this or submit. And as we can see, yeah, this was a faster solution, but constant time sorting. I mean, linear time sorting. So yeah, I'm gonna make another video like in a couple minutes doing another problem that involves the constant time sorting. And then I'll do the daily because the dailies are hard and you need to know this to do it. Alright, so make sure to like and subscribe. Come back for another video in a couple minutes.